Hey Stats class, I want to show you how to do a confidence interval for a proportion with your spreadsheet, like a Google Sheet or Excel. Both of these are going to be the same thing. So what I would do here is I would, over here to the column B, I would make labels. So I would label X and N, and then P hat, I'm going to label it dash HAT. And then over here, X is, it says 548. Usually they'll give you that. N is 958. If they don't give you X and N, then they'll give you P hat directly, and you don't need to do this division. But P hat is always X divided by N, and X is always going to be smaller than N. So there's P hat. If it gives you more than that many decimals, you can use the less decimal icon here to only get a few decimal places. Alright, so that's the first thing we need. Now, the second thing we need is the margin of error, E. By the way, you're going to have this on your table formula, like your table of formulas, I should say, on the final exam. So you won't need to memorize this. This will be given to you. But this is the second. We need P hat. We need the margin of error. So to get the margin of error, notice there's all these different things in here. Alpha is the big one that we need. So I'm going to put confidence level. Right here is 90%, so 0.9. Alpha is 1 minus that. So you can do equals 1 minus and click on that, or you could just type 0.1. You see 0.9, 0.1 is the value of alpha. The alpha is always 1 minus the confidence level. Now, notice that's alpha. This is alpha over 2. We're going to have to divide that by 2 to be able to get the critical number. So I'm going to write critical value, CV critical value. And we get the critical value. Notice it says Z, just like we saw in chapter 6, the Z distribution, the standard normal distribution. This is a Z that we don't know, and we know an area, alpha. This is literally that same thing that we saw in chapter 6. So this is equals norm inverse. The number is alpha, not just alpha, but alpha divided by 2. Alright, with a mean of 0 and a standard deviation of 1. Now, it's going to come back a negative number. We just want the positive version of that number. Alright, so all we need to do is, right there in the front, you can just stick a negative, and it'll make it positive. Alright, again, I don't want that many decimal places. I'm going to make it go all the way down to 3 decimal places. Typically, a z-score is 2, but this particular one, for 90% confidence, typically they round it to 3. Alright, so there's Z alpha over 2. Okay, now P hat we've already got. There it is. So that's the P hat in this formula. We need Q hat. Q hat is just 1 minus P hat. So I can do equals 1 minus P hat. So there's P hat, there's Q hat, there's N is right there. Alright, and then there's the Z alpha over 2. That's this. Alright, that's the critical value. Label it critical value ZA over 2 if you want to. Something like that, or just ZA over 2. Alright, but now we want the margin of error. So E, margin of error, that equals Z alpha over 2. That's what we just did right here. That's the 1.645. I'm going to click that. Times the square root, that's SQRT square root. And then what's inside? P hat times Q hat divided by N. So there's P hat. I'm going to click that number. Times Q hat, there's that number, right, divided by N, there's that number. Right, close those parentheses, so there's my margin of error. Again, I don't need that many decimal places. All right, and now I have everything I'm going to need to be able to make this confidence interval. All right, the best point estimate is P hat, so that's that number to 3 places, 0.572. All right, then it wants to know what's your margin of error. That's what we did right here. So to 3 places, 0 to 6. Alright, and then it wants to know the confidence interval. So to get the confidence interval, we make 2 numbers. We call one the lower number and the other the upper number. So the lower number equals P hat minus the margin of error. The upper number is equal P hat plus the margin of error. And so there is my confidence interval. So I'm rounding these to 3 places again, so just be careful rounding. So 546 and 598. Alright, so just take your time going through there. This part right here, the Z alpha over 2 divided times the square root, all that stuff, that's from here to there. is all the stuff we needed to be able to make that. Now I encourage you to practice this over and over and over again. You're gonna have a blank sheet. So none of this is going to be ever. You're not going to be able to sign in and use this. Just remember that procedure. X over N is P hat, and then all of this is in this formula. So alpha comes from the confidence level. I subtract 1 minus confidence level to get alpha. Divide that by 2 when I'm calculating there it is, alpha over 2. Divide that by 2 when I'm using that. You could also do, have an extra line and divide it by 2, and so you can just go straight into there. But just remember, when you do the critical Z, you need to negate it, norm inverse A5 over 2. So there is the procedure to get those lower and upper numbers that you need in there. All right, now once you get a confidence interval, so you can do the procedure to get these two numbers, but once you get the confidence interval, you still need to know what you found. Okay, so in these interpretations, you're looking for the one, number one, that has to have the word confidence in there. So that one's got it, that one's got it. These other two that don't have it can just be eliminated, because the confidence interval is about confidence. And this is the one we want. We're confident in the interval. That's why it's called confidence interval. This one doesn't mention an interval. And we're 0% confident the sample proportion is equal to the population proportion. So it's got to be A. So that's the way that these problems work. Okay. So just kind of look through what it says. Point estimate, X over N. Margin of error, that's all the stuff that we have in yellow to get down to that. That's the hardest part of the problem. And then P hat minus the margin of error, P hat plus the margin of error.